Okay, ladies and gentlemen, this is the first video on completing the square. Completing that's an ugly P. Completing the square. Completing the square. Okay, let's get started here. So, completing the square. Well, to complete the square, the key thing you must understand is a pattern that comes about whenever you're multiplying or squaring polynomials. So here on the screen, notice I have three problems. And notice on the first one, if I was to go ahead and multiply that out, hopefully you understand that squared means I really have x plus 5 times x plus 5. And to save a little work, hopefully you're good enough to do it in your head, but x plus 5 squared ends up being x squared. I get a 5x, another 5x, so that's 10x, and then of course plus 25. Okay? And so we can continue this pattern. First of all, what do I mean by pattern is, notice, obviously the x squared came from the two x's, right? And the 25, of course, came from the 5 times the 5, or 5 squared. Where did the 10x come from, really? Well, wasn't it really the plus 5 here and another plus 5 there? So in other words, 5 was doubled, wasn't it? Now, if you understand that pattern, we can now do the next two problems much quicker. So in other words, if I was doing this next problem below, I know that x here squared has got to be x squared. I know the 3 is going to get squared, and that's 9. But the essential part is, remember, this 3 right here is going to double. And I'm going to have 6x in the middle. Okay, let's do it one more time. On this one right here, I better change colors. That x squared is going to be x squared. The 7, even though it's negative right there, squared is going to be plus 49. And keeping track of your signs, that negative 7 is going to double and give me minus 14x. So right now, pause the video and finish taking notes of what you see here before we change screens. Okay, so by the way, little warning here. What I'm asking you to do, I know I'm asking a lot. Alright, especially if you've never seen this before. Okay, so look at what we have right here. We have a quadratic, right? Well, we're going to solve it by completing the square. Okay, now how do we do that? Well, the first rule of thumb, okay, is we're just going to go ahead and minus 5 both sides. Normally we want it to equal 0, okay? But in this case, we're going to minus 5 both sides. And the idea is the number now is over here on the right side. And we have this nice space here, right? And since we're completing the square, see, I want a number right in here that's better than this 5. Okay? So what number is that? Well, if you remember, looking back at our previous notes, let's see, what color can I use? I guess I'll use purple. Again, does everybody agree that this minus 14x came from minus 7 doubled? The 6x came from the 3 being doubled. The 10 right here came from the 5 being doubled, right? Okay, so we're going to do the same thing and go backwards. You see, this 6 right here came from being doubled. So I'm going to take 6 and divide by 2, right? And so does everybody agree 6 is 3 that was doubled, right? So this value right in here is going to be the 3 squared, okay? Because remember again, follow the red this time, wasn't the 49 the same as the 7 being squared? Wasn't this 9 the same as the 3 being squared? Wasn't the 25 the same as 5 being squared? Yes, it was. So, here's what I have now. X squared plus 6x plus 9 equals negative 5. Oops, I almost forgot one thing. Didn't we just add 9 to this side? Well, we have to add 9 to the other side as well. So let's see what we have now. X squared plus 6x plus 9 equals 4. Wait a minute. Isn't this a perfect square? Now this is a big leap, but again, looking back here, wasn't x squared plus 6x plus 9 x plus 3 squared? Yes, it was. So this is really x plus 3 squared equal to 4. Okay? And, well, if x plus 3 squared equals 4, can't I get rid of the square by doing a square root? So I'm going to square root both sides, and I'm going to get x plus 3 equal to, and that's a 3 there, equal to, and what's the square root of 4? 2, right? The square root of 4 is 2. Now, of course, the square root of 4 is also negative 2. So I have, therefore, x plus 3 equal to plus or minus 2 there, right? Well, can't I go ahead and do minus 3, both sides? So I'm going to do a little erasing here. But before I do, let me pause it, and please think about this really hard. I know it may look confusing, but pause the video and make sure you have this jotted down before I do any erasing. Okay, so I did some erasing. Hopefully you have everything else done. If not, then you're going to have to rewind it. But going back to our problem down here, I had x plus 3 equal to plus or minus 2. Then I decided, hey, why not just do a minus 3 both sides, right? Minus 3 both sides. And don't I have x equal to plus or minus 2 with a minus 3? And of course, if I take 2 minus 3, that's negative 1. And if I take the negative 2 minus 3, I get negative 5. And these two numbers are my answers. What we would call our roots, okay, are x-intercepts, okay, or also zeros. And I think we better stop there, guys. You're probably a little overwhelmed. But anyways, here is a problem I want you to try. Alright? So is everybody ready? Everybody has all that written down. If not, pause it. Okay, so everyone, can you solve this one complete in the square? Pause the video and see if you can do it. Okay, guys, so how did you do? Again, follow my work. I will just highlight it real quickly and our video is done. So using light blue, or I'll use green here. Here was our original problem. Here we added 9 to both sides. Why? To move the 9 out of the way. Here we added 16 to both sides because here I know that half of 8 is 4 and 4 squared is 16. Now we have an equation with this right here, a perfect square. And in red, notice how I did square root of both sides. And here is where I started solving it, over here. And finally, if you look at the light blue up here, that's where I came up with 9 and -1.